Who's just arrived? Abe, can you hear me, Abe?
Yes, ma'am.
Okay, I can't hear you now, Abe. Let me just see. Yeah. Seem to have the same problem as the other day. Let me just see. Abe, speak now, please, for me.
Can you hear me, ma'am?
No, I can't hear you.
Morning, ma'am.
Oh dear, what are we going to do? Guys, will you write, must I proceed and will you write, or must I turn off or must we start again? I don't know what to do. I need you to just write in the chat. Oh dear. Okay, can you all hear me?
Yes, ma'am.
Okay, you can hear me. All right, guys, are you happy if we just proceed? It'll just take too long if I turn everything off. I'm sorry. Yeah, if you just type them in the chat if you have a question today, I'm really sorry. It's obviously something on my computer, but I think it'll be easier if we just carry on. I am recording it, and I'll make sure for Monday that it works. Yeah. Oh dear. Okay, let's just give everyone another minute or so, because we've only got 8 people on, which is not a lot. So those of you who are joining, I cannot hear you, but you can all hear me. So if you've got any question to ask, please just put it in the chat and I'll just keep looking at the chat. Okay, we've got 10 of us, but good morning to all of you. The only good thing about this morning is that we don't have to have masks on and we can keep our glasses on. But other than that, I would rather be in a class, I think. Okay, let me just see if there's anything in the chat. Okay, so if you've got any questions, you just have to put it in the chat, please. And I'm going to mark the work from yesterday, and then we'll carry on. We'll pick up with that example yesterday and then do one with a parabola and then leave you with some work to do. And hopefully by Monday I can get this to work. All right, so we're on exercise 2.1 in your textbook. So you need to have your textbook open, please. You can see mine. All right, and just to go through that exercise very, very quickly and briefly. The question asked to determine whether these functions are relations or functions and whether they're one-to-one or many-to-one. So just and I told you it needed to take you in a total of 8 minutes or something like that. All right, so the first one, a linear function. It certainly passes the function test, the vertical line test, if you move a vertical line over that graph. So it's definitely a function. And it passes the horizontal line test. So the first one is both one-to-one, and it's obviously a function. B, the parabola. The parabola certainly is a function, all right, but it doesn't pass the horizontal line tests, so it's a many-to-one function. And those are the ones we're going to draw today and look at the inverses of that one. All right, C. C is not a function, does not pass the vertical line test. It is a relation. D we talked about yesterday, a vertical line, x equals -1, right? Well, there are 2 lines here, there are 2. Okay, so x equals -1 is not a function, it's a relation, but y equals 2 is a function, but it's a many-to-one function, right? It's a many-to-one function. Is someone writing me a WhatsApp here? I've just got to check that you're not also writing to me. All right, Tetsa, can you not hear me? The other guys can hear me, Tetsa. I can't hear you, though. Tetsa, just write something on the chat here, please. Okay, Tetsa's left. Okay. All right, I'm going to carry on. Please let me know. I've got my phone. Yeah, everyone else seems to be able to hear. Okay, Chetsa, everyone else seems to be able to hear me. All right, so in D, the horizontal line y equals 2 is definitely a function, but it's a many to one function because it fails the horizontal line test. Okay, in E, we're going to draw these today. All right. We're going to draw, not today, but the exponential graph. That's obviously where we're leading to. All right. The exponential graph is definitely a function. It passes the horizontal line test, and it's 1-to-1. It passes the vertical line test and passes the horizontal line test. All right. In F, a hyperbola, you should have got that that it's definitely a function, and it's definitely 1-to-1. The semicircle G, all right, G is definitely a function, but it's not 1-to-1, it's many-to-one. It fails the horizontal line test. And lastly, a circle we talked about yesterday, it's not a function, it's a relation. It's a many-to-many relation. All right, so it really should have only taken you a couple of minutes. If there's anyone have a problem with that, please write now in the chat, otherwise we're going to move on.
Ma'am, for F,
okay,
on the asymptote.
Take your silence that we can move on. All right, so yesterday we drew a graph. We drew the graph of y equals
Type it in the box.
minus 8. So if you just go back to that in your notes, we had the graph of f of x. Okay, Tom, you have to, what's your question, Tom? You have to write it here. No. Okay, having an asymptote doesn't. Okay, Liam, I can't hear any of you. That's why you have to write your questions in the chat, please. All right, otherwise we have to turn this all off and it'll take the whole lesson, and I don't want to do that. So we decided that we're going to just write the questions in the chat, and I'll keep looking at the chat to see if there are questions. But the asymptote won't affect it at all. That just affects your domain and your range, obviously. You still look at the group you look at the graph and you see whether it passes the vertical line test. If it passes that, it will make it a function. And then once it's a function, you can do the horizontal line test on to see whether it's a 1-to-1 or a many-to-one. All right. Okay, so if you go back to yesterday's drawing, f of x equals 2x minus 8. All right, and we drew it. And you've got it in front of you. I'm going to just draw it very quickly because we ended up with that lesson. All right, it's going to go through minus 8 here, and it's going to go through 4 here. And we drew it. Let's draw it as a solid line. All right, that's a function, and it's 1-to-1. We know that. Now we asked you to draw its reflection about the line y equals x. My graph's not going to be beautiful because it's hand-drawn. But we drew in the line y equals x, and we reflected the black line about that line. And so 4 naught becomes 0.4 up here. All right. And 0 minus 8 becomes minus 8 naught on the x-axis. All you do is you interchange x and y. And we drew those two. Now, this is not beautiful because they did meet. And they must meet on the dotted line. The black and the red one must meet on the dotted line. So my black line is bad. We will fix it up. All right. They must meet at that point. Okay. And so the red line is the inverse or the reflection about the line y equals x of the black line. Okay. It is the reflection about the line y equals x, and its other name is its inverse. So the red line, we have its notation. We said yesterday is f to the minus 1 of x. That represents an inverse. And right at the end of the lesson, we found the equation of the inverse. And the equation of the inverse, you interchange x and y. So your y becomes x. Your x becomes y. and you make y the subject of the formula, and you're going to get x plus 8. And we landed up with y equals x over 2 plus 4. And that became our inverse function, and it is a function. And it's a function because it passes the vertical line test, and it is also a function because our original graph was 1 to 1. And so your f to the minus 1 of x is x over 2 plus 4. And that's kind of where we left off. So the things to remember here, an inverse is a reflection about the line y equals x. And how do you find a reflection, this inverse? You interchange x and y. So the range becomes the domain, and the domain becomes the range. And in the case of a linear function like this, because our original function was a 1-to-1 function, our inverse is going to be a function, which it is. And so we can use functional notation for it. The one thing we didn't do yesterday, and I'd like to do that before we move on, how do we find this point of intersection between the function and its inverse? So I'm going to have to answer my own questions today. To find the point of intersection, all right? Yeah, Chetsa can't hear. Let me just tell Chetsa that I am recording the lesson. Chetsa, just let me tell him. Sorry, guys. It's obviously not a day for technology. Okay, thanks, Nicholas. Thanks. You're doing it quicker than I am. Thank you. All right. So to find that point of intersection, all right, if you find that point of intersection, you can put the two equal to each other and solve them. So I'll ask you to do that quickly now with me. Put the function equal to its inverse. The function was 2x minus 8. The inverse is x over 2 plus 4. And solve that. So we're going to get 4x minus 16 equals x plus 8. All right, so 3x equals 24. So x equals 8. And therefore, your corresponding y value, you can go to either graph. So I'm just going to go to my function. So 2 8s are 16 minus 8 is 8. And anyway, it lies on the line 8, y equals x. All right. So your point of intersection is going to be 8, 8. I'll move this up so you can see it. So really simple, not particularly difficult for a straight line or linear function. All right, so now we're going to go on to a parabola. And we're going to just start with a very basic parabola. Quadratic function. Have I missed a question here? Just let me look. No. Okay. All right, so I want you all to draw the basic function for me, y equals x squared, please. Very basic graph. You don't have to make it large or anything fancy. So we're going to go on to the function f of x equals x squared. And if you will draw that basic function for me. Okay. Okay, just like you did in grade 10. Really simply, it doesn't have to, it's just a sketch. Okay, and that's the graph of f. Turns at 0, 0. If you want to put some points on it, you know that the point is going to be -1 with 1 and 1 with 1. 2 points on the graph. All right, so what you had to do for homework was you had to establish, is this a function? And it's definitely a function. But this one is now, it doesn't pass the horizontal line test. This one is a many-to-one function. All right, so now we're going to reflect this graph about the line y equals x. Okay, so drawing the line y equals minus x. So through the origin, through 1, 1. Draw in a dotted line of where you're going to reflect it. And then, if you can be one step ahead of me, if you will reflect it about that line, reflect it about y equals x, okay, and see what you get. So 0, 0 stays 0, 0. That point stays on the graph. 1, 1 stays on the graph. It's the same. But now minus 1, 1, if you swap it around, becomes 1, minus 1. So for each point, you interchange x and y, and you'll get your parabola. And I think you already said this. John said it yesterday, lying on its side. You've reflected. If you look at those, they're symmetrical about the line y equals x. Okay, now is the red graph a function? Okay, obviously I can't hear your answer, but hopefully you're saying no. All right, the red graph is no longer a function. So this is not a function. So we can't start using functional notation on it. Its inverse is not a function. And why is its inverse not a function? Well, the original was a many-to-one, not a one-to-one. So its inverse will not be a function. So for this parabola, because the parabola is a many-to-one, its inverse is not going to be a function. Now, if we try and find the equation of the red graph, okay, obviously we can't use functional notation, but if we find the equation, we interchange x and y. So y equals x squared becomes x equals y squared. And so y on its own is going to become plus or minus the square root of x is the equation of that inverse, but it's not a function. Okay, it's not a function, and that's the equation of the red graph. You can't start using functional notation on that because it's not a function. Okay, please put something in the chat if you don't have a clue what I'm saying. Okay, I'm just going to leave that for a minute for you to either finish taking it down or to take it in and to think about whether you've got a question. Okay, so how do we deal with this? Sorry, ma'am, are we allowed to use the functional? Yeah, you can use the functional notation for inverses, but not this inverse. Can't use it on this inverse like this. You can't put f to the minus 1 equals plus or minus root x. All right, because then you're saying for that x value, for every x, y can have two answers. So you cannot use functional notation for this red graph at all. So you would have to just call it y equals. That's the equation of that graph. Okay, so how are we going to solve this with parabolas? Well, if we restrict part of the parabola, if we only draw part of the parabola that is a function, then we can find its inverse and use that is a function and use functional notation. So bearing this in mind, I'm going to only draw part of this parabola. I'm going to restrict its domain. If we restrict its domain, then we can have the inverse that is a function. So we have to restrict the domain such that the original graph is 1-to-1. So bearing this in mind, we're now going to take that same function, but we're going to restrict the domain to, so restrict the domain. We're only going to draw it for x greater than or equal to 0. So as long as we do that, if we now draw this, with a restricted domain, we're only going to get that part of the parabola. Now, by doing that, that is going to be a function and one-to-one. Okay, so Luke, I hope I'm making sense. Now we've made this into, it's definitely a function, and it's definitely one-to-one. Passes both the vertical and the horizontal line test. So now if we look at the inverse of this graph, so we're going to draw in the line y equals x. Okay. And then we're going to draw its inverse. Well, the point 0, 0 stays the same, and so does 1, 1 stay the same. And now you're going to draw your inverse to look like that. And now you can call it the inverse, because now the inverse is a function, because you made your original graph one-to-one, because you only drew part of it. And so what would the equation of this inverse be? Well, it would be f to the minus 1 of x equals, all right, and it's going to be root x, just the positive root x. It's just part of the whole inverse. Okay, and here, all right, and you would only be drawing this for x greater than or equal to 0. Because here, if in the original, your domain was x is greater than or equal to 0, and your range is y greater than or equal to 0. And remember, these two swap, so your domain is x greater than or equal to 0, and these two swap, and y becomes greater than or equal to 0. And now you have an inverse, which is a function because you restricted the domain of the original graph. I hope that makes sense. Okay, you should also be asking the question, well, can we restrict it to the other side? Right? Can we draw same function? So the same one, f of x is equal to x squared, but now we restrict it to x less than or equal to 0. Okay, arrived. Can we only use f to the minus 1 if the inverse is a function? Yes. You can call it y equals something like I did here, all right? You can call this y equals that. That's the rule, but that rule, that's a relation, not a function. So you cannot use functional notation on something that's not a function. Like in a circle, you can't use functional notation for a circle. You can use functional notation on a semicircle because you've restricted the circle. You've only drawn part of it. You've only drawn a part that is a function. So functional notation is for functions only. Okay, you can only use it when the inverse is a function. Yes, definitely. Only when the inverse is a function. All right, so if we do the other side of this parabola and we restrict this side. Okay, so there's my function. And I'm restricting the domain to x is less than or equal to 0. So we know the range is y is greater than or equal to 0. That's my function. Draw in your line y equals x. And it's reflected. Remember, on the original, we're going to have a minus 1, 1. Okay, now reflected about the line y equals x. Okay, to get your inverse. So to get your inverse, the 0, 0 stays the same, but now you're going to get 1 minus 1. You swap around x and y. And so your graph's going to do that. And the red graph is a function now. Because you made the original graph one-to-one, then the inverse will be a function. And the equation of this inverse will be minus the root of x, the other half. just that. And that is a function, so you can use functional notation. Now, what will its domain be? Well, its domain is going to be the range of the original graph. You said they swap. So its domain is going to be x is greater than or equal to 0. But now its range is going to be what the domain was of the original graph. So y is less than or equal to 0. So all it's saying is by restricting either the domain on the original graph and making the original graph into a one-to-one function, then you can get an inverse that will be a function. Okay, so if there are any questions, please will you put them into the chat. If you're happy with it, can someone maybe just put in the chat that no, it's all okay? Because all right, and then they're going to be all good. Oh, good. Thanks, John. Appreciate that. All right, so there are going to be 2 exercises you're going to work on. And hopefully you can do it now in this time. And then you won't have too much homework for the weekend and you can get on with all the other stuff. So on Monday, we can go on to an exponential graph and then see how we find the inverse of that. That's the idea for Monday. And hopefully we'll have everything working. Right, so there are 2 exercises. I'll put it on the thing now. And then you certainly will have some time now to go and work on it. So it's exercise 2.2. Page 57. Exercise 2.2, page 57. Hope you can see all that. Let me get rid of the chat. Okay. And I just want you to draw one of those graphs. So we're just going to do C. If you want to do more, you can. So just do C, but you obviously have to answer question 1 to 4 for C. You have to answer the questions 1 to 4 for C. Okay. Then in exercise 2.3, it's page 59. All right. I would like you to do questions B and C. Questions B and C for me, please. All right. So that is, if you've certainly got 15 minutes now, at least, to do that. Shouldn't take you much longer than that. If you'll complete that for homework, and on Monday, I've definitely recorded this lesson. So for those of you, I'm sorry there was no sound for you. It was we definitely are learning to become resilient and deal with challenges this year. All right, so if you can do that for me for homework for Monday. Monday is also an online lesson, and then Tuesday we're back in class. All right, so to all of you, have a nice weekend. A couple of you have got a few things that you need to hand in to me, so if you'll make sure that you do that. And for the rest, thanks, guys. Sorry for sound issues. But thanks, you may go, and have a good day, all of you.
Thank you, ma'am.
Thanks, everybody.